Hey guys, so we're going to go through Unit 7, Lesson 2, and we're going to go through the math problems for this lesson. And again, these will show up on your quiz and on your test. And so get a piece of paper, write it down along with me. And if there's a part where I'm not explaining it very well, just come to my classroom and say, hey, this part of the video didn't make sense to me. Or whoever your teacher is, go to them and say, hey, this part didn't make sense to me, and tell them what part didn't make sense, and we will help you out. So just to review, there are two main equations that you need to know for this lesson. The first equation, I like to call it QSMAT, and you will use this anytime you see the word calorimeter. If you see calorimeter in the problem, you will use this equation for it, okay? The second equation is kind of this one right here, where you look up delta H of each type, and you look it up in a data table called table B12. So you need to have table B12 pulled up. Hold on, let me make sure I'm sharing this. You need to have table B12 pulled up in your chemistry reference guide. So click on your chemistry reference guide or look at the link that I'll put in the YouTube video and go to table B12, because we're going to need to use this in order to solve these problems here. And so let's just go ahead and get started. I'm going to start with problem number 9 in your lesson. Okay. Okay. So I just want to preface by saying that this problem that we're doing is problem number 9 in your lesson. It says you're conducting an experiment using a calorimeter with 500 mils of water in its outer chamber to determine the enthalpy of a reaction. The initial temperature of the water is 25 degrees C. So I'm going to write some of this down. My volume is 500 mils. Okay, so, and that's 500 mils of water. So just look at what I'm writing down. I'm just reading the problem, okay? The initial temperature, so that's my T1, is 25 degrees. I'm not going to bother converting it to Kelvin. After the reaction, the temperature of the water, so afterward, my T2 is 32.5 degrees C. Disregarding any heat loss to the walls of the container, calculate the delta H of the reaction. So that's what we're trying to find. That's our X. Delta H of the reaction is the same as Q, or it's kind of equivalent to Q. So we're just going to call that Q. And so that's what I'm solving for. Okay. It says the specific heat. So remember, specific heat is a C like that, C specific. CS, and it is 4.18, and then it's got some weird units there like that. Okay, it says calculate that. So I know my equation is Q equals C times M times delta T. I have my C and I have my delta T. I can figure out my delta T right here. Delta T means change in temperature. So to figure out how my temperature changed, I can just do T2 minus T1. So 32.5 minus 25 is my delta T. T2 minus T1 is 7.5. Okay, so that's my delta T. But what about my M? Well, it says I have 500 mils of water. Basically, you should have memorized, or they want you to memorize, that the density of water, I'll put it down here. Density of water is 1.0 gram for every 1.0 milliliter. That means that if you have 1 milliliter of water, you have 1 gram. If you have 2 mils of water, you have 2 grams. So 500 mils of water, if I want to convert that over to grams, see how my milliliters cancel out? It's just going to be 500. 500 mils is 500 grams. Okay, so if they give you the volume of water, you can very easily convert it to grams. If you need to Google it to double check yourself, you can if you're nervous about it, but it's just a one-to-one relationship between mils and grams. And so I now know my C. It is 4.18 joules per gram times Kelvin. My mass is 500 grams. And my delta T is 7.5 Kelvin. And look at how my units cancel out. This is my favorite part. I'm going to zoom in because canceling units out is like so satisfying. Okay. So look at how my grams are on top here. This is on top and it's on bottom here. So they cancel. My Kelvin is being multiplied on top here and it's on bottom here. So they cancel. So what units are we left with? Joules, which is perfect because that is the correct unit for Q. And so I know that my units have all canceled out. That is so satisfying. So I'm going to do 4.18 times 500 times 7.5, and I get 15,675 joules. I think that they want the answer to be in kilojoules. Kilo means 1,000. So for every 1 kilojoule, we have 1,000 joules. 1 kilojoule is worth 1,000 joules. So we need to take our answer and divide it by 1,000. So whenever I do that, I get 15.675 kilojoules. And last but not least, did our temperature rise or fall? So our temperature rose. Our temperature got higher. If the temperature rose, the reaction is exothermic. The substance is giving off heat into the water. It's giving it off. So from its perspective, if it's giving away its energy, it's going to have a loss. So it's actually negative 15.675. So you just need to kind of flip the sign, because from the perspective of that thing, it's losing that heat. And so we do like a negative sign, like it's being withdrawn from that heat. If you see calorimeter in the problem, you will use this equation for it. So we just solved the, problem number 9 for the QSMAT problem. This is problem number 10 in your lesson, okay? This problem says find the delta HR. So we're still trying to find delta HR, but it doesn't give us anything about calorimetry. It tells us a reaction. So when you have a problem that tells you an equation, gives you an equation rather than a reaction, the equation that you're going to use is this one right here. You are not going to use QSMAT. So when you have a chemical reaction like this, delta HR, you're going to use this one where you take the H of the products and you add them up, and then you subtract the H of the reactants. Okay, so it says find the delta HR. Well, we're going to find it by subtracting this out. So what are our products? Remember that products are on the right and reactants are on the left. And so make sure you take notes and follow along with me here. So we have 2 products. We have MgO and we have CO2. Those are my 2 products. And now I'm going to subtract out my reactant, which is MgCO3, like that, right? So H products minus H reactants. We need to go look up the H value for all of these. So what does that mean? What is H products and H reactants? You need to go to table B12 in your chemistry reference guide, which is page like 58 of your chemistry reference guide. You can do a control F search for table B12. And look at this. Do you see how these all say, this column says delta H? And so the values are all listed here, and we just need to find them, okay? So let's look at our first one, which is MgO. MgO. So we need to go find Mg. Mg stands for magnesium. And let's see if we can find MgO. Okay, I see MgO right here. And MgO is right here. And then this column tells us the delta HF value. So this is our value for MgO. So I'm just going to go back over here and copy that over. It was like negative 601.24. Okay. Plus, and now we need to do CO2. It needs to be CO2. Sometimes you have to look at this state that it's in. It's CO2 as a gas, or G. So CO2, that's carbon dioxide. Let's see if we can find it. Okay, here we go, right here, CO2. Its value is negative 393.5. So plus negative 393.5. What does plus negative mean? Well, if you're adding a negative, you're just like plus negative, you can just say minus. If you're adding a negative, it's going to be negative. So I'm just going to write it like that. Minus, and now we need MgCO3, which is magnesium carbonate. MgCO3 is right here, and this is its value, negative 1,111.69. And I need to make sure that I enter all of this correctly. And also take note that the units of this are going to be in units of kilojoules per mole because that's the unit provided up here. And we're just like adding and subtracting everything. So my answer will be in units of kilojoules. Whoa, what's happening? Kilojoules per mole. All right, now I'm going to input this in the calculator. I want to show you how I do it so that you can do it too on your quiz and test because you got to do it there too. So look at how I enter it here and kind of follow along. Hopefully you write those numbers down. If not, then go back and write them down so that you can see how I enter them here. See how I do all these parentheses here? And my answer is 116.95. 116.95. Let me double check and see if that is an answer for y'all. Yeah, so we're going to round that up to, I bet that it's going to be 117.0. So that just rounds up to the answer that you see there for problem 10. So this is problem number 10, and that's the answer. Let's look at problem number 11 now. So again, it wants us to find delta HR, and it gives us an equation. So are we going to use QSMAT? Or are we going to use the H products minus H reactants? Well, when they give you an equation, you use the products minus the reactants. So we need to find the H of the products, of all the products, and then we need to find the H of the reactants and then subtract them. So what are my products here? These are my products. So I'm going to write that down. And this time, do you see how that has a 2 in front? So I need to do 2 times the KNO3 value for that one, plus PBI2. That one does not have a coefficient in front. So it's just regular PBI2. Those are my products. So that's what goes right here. My reactants are 2 times KI plus PB. And I'm going to do parentheses around them, though, so that I don't get confused. So I'll do 2 times KI plus PB NO3, NO3 2, like this. So again, these are my products. These are my reactants. And when there's a coefficient, you multiply. And for your products, you're adding the products up together. And for the reactants, you're adding the reactants up together. And then you take the difference between them right here. Okay? So now we need to go pull up all of these values. So we need to find KNO3 because this is our first one right here, right? So going to my table here, I'm going to find potassium nitrate, which is KNO3. You should know, do you see how this says S right here? S. Ours says AQ. So technically those should match up, and that's a mistake. In the chemist reference guide, they should provide the value for AQ, and yet they don't. And if they ever don't provide that direct value, but it's like close, like there's an S instead, just go with that one. But they really should provide the exact one with like the AQ next to it. So negative 492.71 for that one. So it's going to be 2 times negative 492.71 plus, okay, now we need to find PBI2, and it should be PBI2 as a solid because it says S next to it. So let's see, lead is PB. So PBI2 right here, there we go, negative 175.39. So see how we're just like looking up the values and plugging them in. It's kind of enjoyable for me. I know that's kind of silly to say, but we're just like pulling them up and finding them. Now we need to find KI. Here's KI, negative 327.90. So 2 times that. And now we need to find PbNO3 2. I kind of wrote that weird. That's a parenthesis right there. PbNO3 2. Okay, so here it is right here. Negative 451.9. Remember that we're only getting it from the first column. We're not getting it from any other column. Negative 451.9. All right, and now we need to plug this in very carefully. So you can look at how I do it. And if you're being thorough, you should be plugging this in too. Just double check that you understand for your quiz. I'm sure you are doing that right now, right? You can pause it if you need to, though. Okay, negative 451.9. You got to make sure you get all those negative signs correct there. Okay, and I get negative 53.11. Negative 53.11. Let me see if that is a good answer option. Yep, it is. And that is kilojoules per mole. For whatever reason, they just have it in units on your, like this is your answer right here on your lesson. So there you have it. You have all the answers to your problems here. And if you need any more help, please come to my classroom or go ahead and try your quiz and then come to my classroom if you need help or whoever your teacher is, and we will help you out. Have a great day.